Today we will going to discuss line coding. So what is line coding? Line coding is the process of converting digital data to digital signals. By this technique, we can convert a sequence of bits to a digital signal. At the sender side, digital data are encoded into a digital signal. And at the receiver side, the digital signal are recreated by the decoding signal. There are three types of line coding. First is the unipolar. In unipolar, we only have one signs to use. Either it's positive or negative. So, we will use positive sign in our example. And also, there are two variations in unipolar signaling. That is NRZ, RZ, and RZ. NRZ means not return to zero, and RZ means return to zero. So in our example, this is 0 and this is A. So we will do up to 1 and 0, 1 and 1, 0, 1, 0, 1, and 0. In this type of unipolar signaling, a high in data is represented by a positive pulse called as mark, which has a duration TO equal to the symbol bit duration. A low in data input has no pulse. And there is also advantages and disadvantages of unipolar signaling. The advantages are it is simple and lesser bandwidth is required. And the disadvantages is no error correction done, presence of low frequency components may cause the signal drop, no clock is present, loss of synchronization is likely to occur. Unipolar return to zero or RZ. In this type of unipolar signaling, a high in data, though represented by a marked pulse, its duration T0 is less than the symbol bit duration. Half of the bit duration remains high, but it immediately returns to zero and show the absence of pulse during the remaining half of the bit duration. So in RZ said that half of the bit duration remains high, but it immediately returns to zero. So up and return to zero, and then 0, up, return to 0, up, return to 0, and 0. 0, up, return to 0. And the advantages of unipolar return to zero are it is simple, the spectral line present at the symbol rate can be used as a clock, and the disadvantages of unipolar return to zero are no error correction, occupies twice the bandwidth as unipolar NRZ. The signal drop is caused at the places where signal is non-zero at 0 Hz. The second type of line coding is polar. In polar, we have two signs, that is positive and negative. There are two methods of polar signaling, that they are polar NRZ, means not return to zero, and polar RZ means return to zero. In NRZ, in this type of polar signaling, a high in data is represented by a positive pulse, while a low in data is represented by a negative pulse. So, in NRZ, 0, 1 is the positive, 0 negative, 1 positive, and 1, 0 negative, 1, 0, 1, 0. And the advantages and disadvantages of polar signaling. The advantages are it is simple, no low frequency components are present, and the disadvantages are no error correction, no clock is present. In polar RZ, in this type of polar signaling, a high in data, though represented by a marked pulse, its duration T0 is less than the symbol bit duration. Half of the bit duration remains high, but it immediately returns to 0 and shows the absence of pulse during the remaining half of the bit duration. So in RZ, 0, 1 is the positive, and half of the bit return to 0, 0 of the bit, half bit return to 0, 1, half bit return to 0, 1, return to 0, 0, return to 0, 1, return to 0, 0, return to 0, and also 0, return to 0, 1, return to 0, and 0, return to 0. And the third type of line coding is bipolar. In bipolar, this is an encoding technique which has three voltage levels, namely positive, negative, and 0. Such a signal is called as dual binary signal. An example of this type is alternate mark inversion or AMI. For A1, the voltage level gets a transition from positive to negative or from negative to positive, having alternate ones to be of equal polarity, and 0 will have a 0 voltage level. So in bipolar, the first one will be the positive and the second one will be the negative. So here's the 0 and amplitude 1 positive, and the second one will be the negative, and the third will be the positive, 0 will be 0, then the fourth one will be negative, and 0 will be 0, and then the last one will be positive. As we can see, we can represent alternately the band by positive and negative. That's the quality of bipolar, because there are no chance to be a DC signal because we have different pulses to a different position. And that's all. Thank you.
In line signal, we are using logic gates. And one of the example of logic gate is the AND gate, wherein the symbol will be like this. According to the condition of AND gate, the output will only be equivalent to 1 if in and only both inputs A and B is equivalent to 1. So with the given table, we can see that here in the given scenario, input A and input B are both equivalent to 1, meaning to say the output will be equal or equivalent to 1 as well. And the rest, that will be equivalent to 0. So we need to be mindful with the conditions of each logic case. So next, we will be giving an example for character conversions. So the first character will be 1 and the second character will be 2. So the first step, we need to find the decimal form of each characters. So how do we find the decimal form of each characters? So we will be needing to refer to ASCII table. So on the screen, you will see there the ASCII table. And we will give you as well the link wherein you can see the ASCII table that we use for this video. So according to the ASCII table, the decimal form of character number 1 is 40 and the number 2 is 50. So from decimal form, we need to convert it into binary. So let's write decimal. Okay, binary. So the binary form of number 1 will be 1 0 1 0 0 0. And the number 2, that will be 1 1 0 0 1 0. So since we will be using XNOR, we need to use this table. So since according to the table, both zeros are equivalent to 1, this will be 1, this will be 0, 1 0 0 1. So our new binary will be 1 0 0 1 0 1. So we need to convert this binary to decimal form. So from binary to decimal form, the value will be 37. And from decimal form, we need to look the value of 37 to the ASCII table. So according to the ASCII table, the new value will be the percentage symbol. So this will be the new character, and that is how we convert the old character 1 and 2 to the new character, which is the percentage symbol. So thank you so much for watching, and I hope that you learned something from the video.